let us now learn how to create the workflow to calculate the cost of the given part. So this is the part for which we will calculate the cost now. This is the mesh from IAPT, and in order to find the component LBM costing, we can navigate to this tab AM, and inside the subcategory analyze we will find this component LBM costing. So we can place this component onto the canvas, or we can also search in the radial menu like this LBM costing. So let's turn this off for now, and here we see that the main input is the mesh for which we want to calculate the cost. And then here we have like the other inputs such as the overhang angle, the angle at which the overhang surfaces have to be supported, that can be defined here. And then here we can highlight the surfaces that need support. So if we turn this on, here we can see that these are the surfaces that need the support structures. And here we can also turn this on fill platform, so that it automatically fills the whole build platform with the number of parts. And here in the part orientation, we can define the angles at which the part has to be oriented in the build platform about X, Y and Z directions. For example, if we change the angle in X direction, here we can also observe that the number of parts has increased. So this orientation angles has also effect on the total number of parts that can be printed on the build platform. In the later sessions, we will learn how to come up with the best orientation in order to print more parts or reduce the cost. And here we can define the dimensions of the machine that we will use for printing the part. And here we have other parameters such as the material price, density of the material and the support, and the depletion, the amount of material that cannot be reused again, the build rate, which is in cubic centimeters per hour, the layer height of the material in millimeters, and the time required to prepare the machine, the hourly rate of the machine. And here we have the other costs such as personal cost, optional cost and additional costs. So in order to get the accurate cost to print the parts on the build platform, one has to define the parameters correctly. So these are the important inputs that are required to calculate the cost. So let's have a look at the output. So here we get the total cost to print all of these parts, and then here we can also get a nice report that shows the total cost, the build time in hours, and the total number of parts that can be printed and the cost per part. And here we can also get the part meshes, that is all the meshes of the parts on the build platform. And here we can also get the support surfaces as meshes. So here we can see that these are surfaces for all the parts that needs the support structures. And here we also get a transformation matrix for each of the part from the initial position onto the build platform. So here we see that this is the basic setup to calculate the cost, and here we also observed what are the inputs required. As we see that this is a parametric setup, I can simply switch between different part. Now here we have another part, and I will just connect the cable from this part to the other part, and here we can see that it automatically calculates the cost for the new part and the number of parts for the same machine, and also the support surfaces here we can see. So of course, when we change the part, one also has to keep in mind the part orientation that could be changed for each part, or the costs or the material of the part and so on. But nevertheless, the main idea is that here we have built a parametric workflow such that it can be used for any other part. So let's move on to the next session.